With Windows Server 2008, Active Directory integrated zones can be configured with one of three different replication scopes, which is to say that their information can be replicated in three different ways. First one, to all domain controllers in the domain. This is actually the only replication scope that it was available in Windows 2000 as well. Second, to all domain controllers that are DNS servers in the local domain, also known as the Domain DNS Zones application partition. And third, to all domain controllers that are also DNS server in the entire forest, also known as the Forest DNS Zones applications. A DNS server can host a single DNS zone or it can host multiple DNS zones. The following factors determine how DNS zones are deployed. First, ADDS site structure. When you deploy a large ADDS environment that spans a number of geographic locations, you use sites to manage the replication of the traffic between these locations. These sites are designed to limit the replication traffic across the WAN links, as this traffic can affect the performance for clients and users. Although multiple ADDS sites might not require multiple domains, each site has to have at least one DC for managing requests from the local clients. Second, the distribution of an IT department. How your network is administered helps determine the layout for your DNS zone and servers. In a company with a centralized IT management structure, maintaining fewer DNS zones is easier because one group has the responsibility over the entire infrastructure. On the other hand, in a decentralized IT management structure, where multiple IT departments are responsible for different parts of the network, delegating the zones to these departments can alleviate the management issues by assigning the DNS record management to the people responsible for each particular area. And third, the security needs that your company have in terms to the access to the DC or domain controllers in the forest. Windows Server 2008 DNS implementation supports two types of forwarding, standard and conditional. A standard instructs a DNS server to forward all of the queries for DNS domains not hosted on a server to another server or servers. On the other hand, the conditional instructs a DNS server to forward non-authoritative queries for a specific non-hosted domain to a specific DNS server or servers. In cases where a standard or conditional forwarders are created, the conditional forwarder for a specific domain is used instead of any server-based standard forwarders. Windows Server 2008 DNS supports the DNS Dynamic Update Protocol, which enables DNS clients to dynamically update their resources records in DNS zones. You can specify that the DHCP server in your network dynamically update DNS when it configures a DHCP client computer. This reduces the administration time that is necessary when manually administering zone records. You use dynamic update feature in conjunction with DHCP to update resources records when a computer releases or updates its IP address. Client computers running Windows 2000 or later attempt to update the A record directly, but they utilize or use the DHCP server to dynamically update their pointer records or PTR records. DHCP-enabled client computers running earlier versions of Microsoft operating system are unable to update or register their DNS records directly. These DHCP clients must use the DHCP service provided with Windows 2000, Windows Server 2003, and Windows Server 2008 to register and update both their A and PTR records on behalf of these down-level clients. Although dynamic updates allow clients to update DNS records, this is not a secure method. A more secure way of updating DNS record resources is using the Secure Dynamic Update. The server attempts the update only if the client can prove its identity and has the proper credential to make the update. Secure dynamic updates are available only through Active Directory Domain Service and when Active Directory Domain Integrated DNS is enabled. By default, Active Directory Integrated Zones allow only secure dynamic updates, though this setting can be modified when you create the zone. If you create the zone on a standard primary zone and then you convert it to an Active Directory Integrated Zones, it preserves the primary zone dynamic update configuration, which can be changed using the DNS MMC console. You can configure dynamic updates for DNS zones to use one of the following options: none, non-secure, unsecure, and secure only. None means that no dynamic updates are permitted. All DNS entries must be created manually. Non-secure and secure allows client to first attempt a non-secure dynamic update, and only if that one fails to attempt, then they try with the secure dynamic update. And the secure only is the option that is only available on DNS zones that has been configured on Active Directory domain controllers. Traditionally, the DNS administrator manually adds or deletes resources records from DNS zones files as required. With the dynamic update, individual computers and services are able to automatically add, update, and delete DNS resources records. Dynamic update ensures that the records are up to date and guards against accidentally deletion of resources records by the DNS administrator. Over time, stale resource records accumulate in the DNS database. Records become stale, for example, when computers, especially those of mobile users, abnormally disconnect from the network. A stale record provides outdated and inaccurate information to clients, take up unnecessary space, and can possibly degrade server performance. Windows Server 2008 provides a mechanic calling scavenging to remove these records as they become out of date. Windows Server 2008 adds a timestamp to dynamically added resources records in primary zones, where aging and scavenging are enabled. Records added manually are time-stamped with a value of 0, which indicates those records should be excluded from aging and scavenging process. Since the secondary name servers receive a read-only copy of the zone data from the primary name servers, only primary zones are eligible to participate in this process, or in the Active Directory integrated zones, in this case AD integrated DNS. Server then can be configured to perform recurring scavenging options, and they can do it in the operations automatically. Or you can initiate a manual and immediate scavenging operation at the server. DNS scavenging depends on two settings. First one, no refresh interval, which is the time between the most recent refresh of a record timestamp and the moment when the timestamp may be refreshed again. When scavenging is enabled, this is set to 7 days by default. And second, the refresh interval, which is the time between the earliest moment when a record timestamp can be refreshed and the earliest moment when the record can be scavenged. The refresh interval must be longer than the maximum record refresh period. When scavenging is enabled, this is set to 7 days by default as well. A DNS record becomes eligible for scavenging after both the no refresh and the refresh intervals have elapsed, for a total of 14 days by default. Scavenging is enabled on per zone basis and is disabled by default. You should not enable DNS resource record scavenging unless you're absolutely certain that you understand all of the parameters and the configuration and how to configure them correctly too. Otherwise, you might accidentally configure the server to delete records that it should retain. If a name is accidentally deleted, not only do users fail to resolve queries for that name, but also a different user can create and own that name, even on zones configured for secure dynamic update.